Got to do this integral. We're going to need to let u be something. This one's a little tricky. What we're going to do is we're going to need to let this piece right here be u. Why so? Well, because the derivative du dt here, what's your natural log? It's 1 over the argument times, well, that's it, 1 over the argument. If the inside was anything other than a simple t, the chain rule would have to multiply, but it's just a simple t. So we stop there, and then we multiply both sides by dt. Cancels out. So du is 1 over t dt. Okay, so let's start replacing all the t stuff with u stuff. I want to make it all u. So what do we get? dt over t times u, right? Because natural log of t, that's just u. All right, so, well, I can rewrite that. That's the integral of 1 over u. Let's just separate these guys. Times 1 over t dt. Just going to separate them. Why? Because then I can see my plug-in. Right? Same thing. U and T are both in the bottom. U and T are both in the bottom. Doesn't matter what the order is. DT is in the top. It's over 1. It's all the same. And now we can do it, huh? So 1 over T dt, that's just du. 1 over T dt, that's just du. So this becomes the integral of 1 over u du. So that's nice. Now we can do the antiderivative. What is the antiderivative of 1 over u? Its natural log of absolute value of u. So plug back in, natural log of absolute value. And what's u? Natural log of t. There we go. There is our answer. Now, if you left off the absolute values and just made them parentheses, it'll give you credit, but technically it should be absolute value. See, there's what it should really be. If you wrote it that way, that's fine. But we end up with two natural logs, don't we? Because remember, the derivative of natural log goes back to 1 over the argument, right? So the antiderivative 1 over u is natural log of absolute value. And then the u itself on the inside is also natural log t. So we end up with double natural log. And so there we go.